numbers, we're going to fill in the blanks where they ask for all the information of the graph. And then by the time we fill in all those blanks, we should then be able to write the equation of the graph. Okay? So, for example number 1, they ask, do we have any x-intercepts? What do you guys think? Do you see any x-intercepts on this graph?
Yes.
Where at? -2. Perfect. Okay, so we got a point right here at -2. So we have an x-intercept at -2, 0. Okay. What about a y-intercept? Do you guys see a y-intercept on this graph? At +2, right up here. Okay. So that would be the coordinate point 0, 2. Perfect. Okay. What about a vertical asymptote? You guys see anything that acts like a vertical asymptote here? Yeah, this part right here, right? It makes those curves get close to it, but never touch, right? So where is that line? Where? X equals -1, yeah. Okay. What about a horizontal line that does the same thing? You guys see one of those? At +1. So remember, this is y equals a number, right? So we see that happen right through here. All right. Okay, what about a slant asymptote? So those are diagonal lines, right? You guys see any diagonal asymptotes? Okay, so no slant asymptotes in this one. Okay. What about any holes? You see any holes on here? No? Okay, so no holes. So they say that should now be enough information for you to write the function, the equation. Okay, so remember your function or your equation starts out with y equals or f of x equals. Okay, and these are always written as fractions, right? In the top of the fraction, what do we always take from the top of the fraction? What do we always find from the top of the fraction? The zeros, the x's, the x-intercepts. So that would be this part right here, right? So we said we had one x-intercept at -2. Well, when it's in the equation, how would I write that I have an x-intercept at -2? X plus 2, perfect. So in the numerator, we should have x plus 2. Perfect, all right? So now we've got the numerator covered. Let's worry about the denominator. What do we usually take from the denominator? The vertical asymptote, right? Domain and vertical asymptote, oops. But we didn't mention anything about domain in these blanks, so that wouldn't help us. So yes, vertical asymptote. How would I write that I have a vertical asymptote at -1 in the equation?
X plus 1.
Right. So in the denominator, x plus 1. All right, so this should be our equation. One way we can double check is that, remember, the entire equation is how I come up with the horizontal asymptote, right? We compare top and bottom. Okay, that's when we use the acronym. So are we bigger on top, bigger on bottom, or the same? Same. So eats DC. So what do I do when they're the same? Divide the coefficients. Well, what are the coefficients of the two x's? 1. So what's 1 divided by 1? So we must have done it right, because this is the correct horizontal asymptote, right? Okay, awesome. Let's do another one. The graph did get a little bit messed up on number 2, guys. That diagonal line should be going right through 0, 0. I don't know why it shifted down on the copies, but on the original that I have printed out here, it is right through 0, 0. And it also, on this curve over to the right, it does have a hole at about 4, 3. So there is a hole printed right there. So if you want to draw you a little open circle. Sorry about that. Okay, so first they ask, do you see any x-intercepts? Okay, so one at -2 and one at +2. Okay. All right, a reminder, guys, that the only real part of the graph are the curves, right? Those other lines are asymptotes. So like this would be like a dotted line, right? Okay. So keeping that in mind, do we have any y-intercepts? No. Because there's nowhere where we actually touch plus the y-axis. Okay? What about any vertical asymptotes? So that's when I'm getting close to a vertical line and not touching it. Do you guys see anywhere that kind of happens? What about this curve right here? What's it getting close to? And what's this curve getting close to? 0. So we do have one there. We just can't see it because it's on the axis, right? So we have a vertical asymptote at x equals 0. Do you guys see anything that's stopping us from going horizontally? No, there's no place like it was for that x value, right, where it kind of curves away. Okay, so that means no horizontal. Okay. Then they ask about a slant asymptote. Do we have a slant asymptote this time? Yeah. Okay. So like I told you guys, it accidentally got shifted down just a little bit, but it should be going through 0, 0, right? So that means the y-intercept of that line is 0. So plus 0. I just need to figure out what the slope is, right? Okay, well, if we were to separate this out evenly, if that's 5, 1, 2, 3, 4, approximately, that's how far apart they would be, right? Okay, and if this is 2, 1 would be right about here. So, if I have a point at 0, 0, and I go over 1 and up 1, I'd be on the line, right? So, that means my slope must be 1, right? Okay. So, my slant asymptote is the equation y equals x. Perfect. All right. Okay. What about a hole? We said we did have one here, right? The hole we said was at 4, 3. All right. And now they want us to write the function. Okay. So, f of x equals... All right, so again, what tells us what goes in the numerator? Right, the x-intercept. So this is what tells us what goes in the numerator. So what are we going to have in our numerator? Minus 4, yeah. Or if you don't want to multiply them together, I'm okay with you leaving it as x plus 2, x minus 2. If you do multiply it together, just make sure you multiply correctly, all right? Okay. How do I know what to put in the bottom? Vertical asymptote. Okay, so this right here tells us what goes in the denominator. So what am I going to put in the denominator? Just x, right? Okay. We said there was no y or horizontal. We did say we had a hole, though. If we've got a hole, what does that mean was in our equation? Something that canceled out. Okay, what canceled out to give us a hole at 4, 3? X minus 4. So I'm going to have an x minus 4 in the top and an x minus 4 in the bottom. All right. Okay, so again, this horizontal asymptote is going to be how we check to make sure we have something that actually makes sense. Okay, so we did not have a horizontal asymptote, right? So does that mean bigger on top or bigger on bottom? Bigger on top. So let's check. X times x times x, that'd be x cubed, right? In the bottom, x times x would be x squared. So are we bigger on top? So that means we did good. All right. Okay. Flip it over on the back. Let's look at one more of these. Okay, on number 3. You guys think we've got any x-intercepts? Okay. We've got 2 of them. Where at?
-3 and 2.
Okay. So at -3, 0, and at 2, 0. Nice. Okay. Any y-intercept on this one? No. Okay. All right. Any vertical asymptotes? At 0, yeah, because we can see these curves get really close to 0, but never cross it. Do you guys see anywhere else where something like that happens? At 5, very good. Okay, so we've got x equals 0, and we've got x equals 5. Nice. Okay, do you guys see any horizontal line where something is curving and getting close to a number? Mm-hmm. Yeah, so we've got -1 right through here. Right? Although we do cross it in the middle section, you guys can tell over here it's getting really close to -1, and on the far side, getting really close to -1, right? Okay, so that means we have a horizontal asymptote at -1. Do you guys see any slant or diagonal asymptotes this time? No? Okay, so no slants. Any holes this time? No. Okay. All right. So we have all of our pieces. Now we're going to write our equation. Well, again, tell me, where do I look to figure out what's going to go in the numerator? X-intercepts. Okay, so this is my numerator information. So what are we going to have in our numerator? Right. Okay? Where do we look to figure out what goes in the denominator? Vertical asymptote. So this part down here tells us what's going to go in the denominator. So what are we going to have in our denominator? X. Right. Oops, x minus 5. All right. Okay, we said there was no y-intercept, so nothing to consider there. No holes this time. Okay, remember, this is how we check, right? Okay, so if we have an actual number, that must be each DC, right? Exponents are the same. So let's check. We've got x times x, that would be x squared. X times x, that would be x squared, so exponents are the same. But with what we currently have, the coefficient in the top would be 1. The coefficient in the bottom would also be 1. 1 divided by 1 is positive 1, and it's supposed to be negative 1. So that means one of those coefficients should be what? Negative. So we need to put a negative in front of our function.
Where does the extra x on the bottom come from again?
Right here. So we don't have to decide which one the negative goes with. We just put 1 in front of the function so that it follows the rule. Okay?
And that's the same for if it's known too, right?
If it's what?
For the vertical asymptote. Because we had one on number 2 as well.
Mm-hmm. Yeah, on number 2, the vertical asymptote was just 0, so we just put the x at 0. The x minus 4 came from the hole, but we didn't have a hole on number 3. Okay. All right, on this last section, guys, it says we're going to use this as kind of like our basis. This is going to be our graph, and then we're going to make the following changes. Okay, well, let's take a closer look at this graph. Where do you guys think that this graph might have some asymptotes? Okay, a vertical one at 2, and also a horizontal one at 2. Awesome. Okay, so I'm going to make note of that over here to the side. So you guys said a horizontal asymptote at 2, as well as a vertical asymptote at 2. Okay, awesome. So keeping that in mind, they ask us to make the following changes. Well, remember, guys, when something is inside the parentheses like that, it moves things to left and right. This one says -2, so specifically we're moving which way? Right. Remember, it's always opposite of what we think. So here we are going to move right 2. Okay. Well, x values are the ones that move left and right. So here we go look. Our x value was at 2. If we move 2 to the right, where is it going to be now? 4. Okay. What does this plus 3 out here on the end tell us we're doing? Up 3. So if I shift up 3 from y equals 2, now I'm going to be at, right. So now we're going to redraw the picture, but with these new asymptotes. So we've got a vertical asymptote at 4 and a horizontal asymptote at 5. And there was no negatives, right? Nothing to flip anything. So that should tell us that the piece in this quadrant stays put, still stays in this section, and the piece in this quadrant stays put in this section. All right. Okay. Number 5. Number 5 does not say anything about moving left and right. What does number 5 say to do? Down. So down 3 places. Okay, so again, I was originally at y equals 2. So if I move down 3 from there, where will I be at now? -1. All right, and I'm not going to change anything about the vertical because they did not say to shift left or right any. So I'm now going to draw a vertical asymptote at 2 and a horizontal asymptote at -1. Again, we didn't have any negatives, so nothing's going to flip around. This piece should stay in this section, and this piece should stay in this section. All right.